Hey guys, so I did another deep dive into protein because I specifically was looking for like why there's so many fat percentage differences and what differences does it make. Obviously calories, it makes a difference, but in terms of other health benefits or downsides, I wanted to look more into that. So let's talk about it. So for this research project, I'm going to be using two sources. I'm going to be using an article published in the Royal Society of Chemistry called Dietary Protein in Human Health by G. Wu in 2016. And then I'm going to be using an article published by the Harvard School of Public Health by T.H. Chan. So the ongoing question everybody has different answers for: how much protein do you need? Okay, so according to Chan, who published with Harvard, most adults need about 0.8 grams of protein per kilogram of body weight. So about 0.8 grams of protein per about 2.2 pounds. And then also is then suggesting higher intakes may help those who are active, elderly, or building/maintaining muscle. So building/maintaining makes me think he's specifically referring to people who already have a larger muscle mass than maybe what their genetic maintenance would be. So if you've already built a significant amount of muscle in your teen and 20s and you're trying to keep it through your 30s, then you probably would need more than 0.8. According to Wu, who published with the Society of Chemistry, he supports the 0.8 kilo per kilogram. He supports the 0.8 per kilogram baseline, but does go on to say that 1 gram to 1.6 grams per kilogram may be optimal for athletes or those under metabolic stress. So again, they're saying everybody should have at least 0.8 per kilogram. But then if you are active, you automatically should be having at least 1 gram per kilogram. Okay, so I'm going to get into comparing the two articles and what they say in plant versus animal proteins. So according to the Harvard article, animal proteins are typically the most complete because they usually contain all 9 essential amino acids in one dish. And examples are obviously meat, poultry, fish, eggs, and dairy. However, they often come with more saturated fat and cholesterol, except for lean cuts of fish and lean cuts and fish. So lean cuts of beef and fish don't have as high as fat and cholesterols than most other animal proteins. And then the Harvard article goes on to say that plant proteins are most often incomplete, but by mixing and matching plant proteins, you can create obviously a complete amino acid profile. And these are things like beans, lentils, soy, nuts, seeds, and whole grains. These are also lower in saturated fats, higher in fiber, and also known to contain antioxidants and phytonutrients. So some better benefits in there, but you need to mix and match more in order to get complete proteins. According to Wu, who published with the Society of Chemistry, he confirms that both can meet amino acid needs, but notes plant proteins have less digestibility due to fiber and anti-nutritional factors. So you will typically have a harder time or take longer to digest plant proteins because they contain more fiber, trypsin inhibitors, and cell wall components. And trypsin inhibitors, I actually had to look up because I didn't know what they were, but they're a compound in plants, mainly in legumes like soybeans and beans, that actually block the digestive enzyme when you first consume it, which is temporarily reducing protein breakdown, whereas when you eat meat or animal products, that enzyme is not present, so it's easier and quicker to digest. Talking about this enzyme, a really good example is chia seeds. So when you cook, soak, or ferment legumes and soy foods, it actually destroys that it actually destroys the trypsin inhibitor, making the plant protein easier to digest, and it makes it more fully nutritious. Fully nutritious. Nutritious? That's okay. Now specifically looking at higher versus low-fat animal products. So when you're buying beef, turkey, or chicken, and it says like 93%, 90%, 80%, 83%, according to Chan in the Harvard article, higher fat meats, such as marbled beef, processed meats, or poultry with skin, usually come with higher saturated fat, which is linked to raised LDL and heart disease risk, but that doesn't mean eating a little bit every other day is going to immediately cause that. Those are also lifestyles that further increase the risk of that. Whereas lean and low-fat options like skinless poultry, sirloin steaks, pork tenderloin, and fish have the same protein content, have the same complete proteins, but they are also typically contain less saturated fats. And fish like salmon, sardines, and trout provide heart-healthy omega-3s instead of saturated fat in general. Of course, then you get into... Okay, I looked it up. I know I've heard before, like, oh, if you only eat fish every day, then you're gonna, like, get mercury poisoning. But I, like, didn't know how true that was. So, essentially, yes, fish contain mercury. But you don't need to really be concerned about it. Because... So in water, there's mercury, obviously, in the environment from volcanoes and human activity. And in water, bacteria convert the mercury into methyl mercury, which accumulates in fish and shellfish. So they almost all have mercury in them. However, larger, older, and predatory fish tend to have higher mercury levels because of bioaccumulation. This means that when they're eating a smaller fish, they're absorbing more mercury than a young small fish who has not ingested or been around as much. So typically, people at risk, like young children, nursing parents, or pregnant women, should avoid things like shark, swordfish, king mackerel, tilefish, and big eye tuna, because these are more predatory fish that are at a higher risk of containing more mercury in their systems. Whereas if you eat salmon, sardines, trout, pollock, shrimp, or canned light tuna 2 to 3 times per week, you're fine. You're not gonna be at risk for mercury poisoning. All right, coming back to comparing high versus low fat animal products. According to Wu, who published with the Royal Society of Chemistry, he recommends favoring, I'm assuming it's a man. Okay, so Wu was just the primary author. Can I find, there were other authors in it. It doesn't give their full name, and Wu is a common last name, so I don't know if it's a man or a woman. Interesting. Okay. My bad if you are a woman. Anyway, so they do recommend favoring unsaturated fat-rich proteins such as fish and plant oils over saturated fat-rich meats for better cardiovascular and metabolic outcomes. But they also note that protein quality and the accompanying fat type both influence long-term health as well as general activity levels and genetic predispositions. So now looking at protein and satiety.
Satiety.
Satiety?
Satiety.
I feel like I've always heard satiety. Satiety, apparently. So when it comes to protein and satiety, according to the Harvard Journal, it notes that protein helps you feel fuller longer than carbohydrates or fats. And so higher protein meals can promote that feeling of being full longer and support weight control by reducing the overall calorie intake that you feel you need. And protein also slows digestion and stabilizes blood sugar, both of which sustain fullness. According to the Royal Society of Chemistry journal, it explains that protein increases the hormones that make you feel the satiety and reduces hunger hormones. So it actually, as it's digesting, interacts with those hormones to prevent you feeling hunger. This was interesting. They also note that protein's higher thermic effect means it actually takes more energy to digest the protein than contributing to a sense of fullness. So you're actually burning calories trying to digest the protein that you just ate, which is affecting your hormones to make you feel fuller. Yeah, so that was another deep dive. I don't remember. Do you know you're licking my shoulder? Yeah, so that was 2 different sources on how much protein we should be having, what kind of proteins, a little side tangent about mercury poisoning. If you have any questions, feel free to drop them. How much protein do you consume? Like, I know I just go into MyFitnessPal and just say I want this % of my calories to be protein, so I don't actually know. I think it's usually pretty close to my body weight, or at least like my goal body weight. It's pretty close to that, so it's got to be pretty close to 1 point something per pound. How do you calculate it? I don't know. My app tells me what to do. All right, guys, till next time. Bye.